Okay, so good morning, afternoon, evening, and good night. All the lecturers, also laboratory assistant. Explain my presentation about materials characterization laboratory, the analytical techniques, a comprehensive overview of 4 essential methods for material analysis. And my MPM number is 240-644-8272. Okay, this is the overview. First is the introductions. That is the overview of the analytical techniques and their complementary roles. Also the atomic absorption spectroscopy. That is the principles, also the instrumentations, the elemental analytes, and also the applications. And the third one is the simultaneous thermal analysis. That is the TGA-ESG, and the principal and thermal behavior characterizations. The fourth one is the UV visible spectroscopy, which is the electronics and quantitative analysis methods. And the fifth one is the FTIR spectroscopy. This is the molecular fingerprinting and functional group identifications. And lastly, this is the summary and the applications, which is the key takeaways and complementary technique selections. Okay, next on the 4 essential analytical techniques. First is the atomic absorptions that measures the concentration of metal elements by detecting light absorptions by free atoms in ground state. Okay, so this is the PPB and PBM sensitivity. Next one is the UV. That is the electronic transitions, measures the absorptions of UV visible light 190-800 nm by chromophores, and also to identify and quantify the molecules. So the third one is the simultaneous thermal. That is the combines the TG and the SG to study the compositions, transitions, and stability. And lastly is the FTIR. That is the functional groups through the infrared absorption by molecular and the unique fingerprint for the compound. Okay, next is the atomic absorption spectroscopy. That is the fundamental principle. AAS measures the elemental concentration by detecting how ground state atoms absorb the light at wavelengths unique to each element. And this is compared also to the Beer-Lambert law. That is the mathematical foundation of AAS, and the quantification is A equals to molar absorptivity and times by the concentration also. And this is also gaining the atomization process, which is the sample pre-introductions, aerosol formation, heat absorption, and also the ground state across. Next is the atomic absorption spectroscopy again, but it is on the instrumentation and applications. So this gather the key components. That is the light source, atomizer, monochromator, and the detector. This also combine the major applications. That is the environmental, food safety, metallurgical, clinical, pharmaceutical, and research. Next is the STA. What is STA? STA combines the thermographimetric analysis, or TGA, and differential scanning calorimetry, and DSG, in a single instrument that measures both of the mass that change and heat the flow from the same sample under the identical conditions. So there are the key advantage. That is the identical test conditions, enhanced signal analysis, differentiation capability, and also the sample efficiency. Also next to the dual measurements approach, that is the TGA, compare the mass charge, and the SG, the heat flow. Okay, moving on to the SDA, another SDA, the applications across industries, the polymers and plastics, pharmaceuticals, metals and alloys, also the thermal reactions. SDA ability is to simultaneously track the mass that change and thermal events that enable clear differentiation. Okay, moving on to the UV visible spectroscopy. This is the principle of operations, that is the electronic transitions. That is UV-VIS spectroscopy measures how molecules absorb ultraviolet and visible light. And second is the Beer-Lambert law. The foundation of quantitative UV-vis analysis of the absorbance is directly proportional to both concentration and path lengths, wavelength regions, and quantitative and qualitative also. Moving on to the UV spectroscopy, this is the picture of the light source and slit, also the monochromator. That is how the UV visible spectroscopy works. So the instrumentations and applications, instrument and components, there are light source, monochromator, sample holder, and detector. And also there are the major applications, that is the pharmaceutical, that is the drug purity, concentrations, also the solutions. Also there is food and beverage, like the color measurements, the chemical MFG, that is the process monitoring, also the environmental, the pollutant detections. Also the fifth one is the DNA RNA analysis, that is the activations, purity assessment. And also lastly the research, kinetics, binding studies, and also the bind gap. There is also the highlights this, that is the single beam versus the double beam. That is like the simpler design from the simple beam, lower cost, versus the better stability and also the higher accuracy of the double beam. Moving on to the last advantage is the FTIR, or the Fourier transform infrared spectroscopy. The principle of operations, molecular vibrations. FTIR measures infrared light absorption by molecules undergoing vibrational transition, and the Fourier transform process. There is the broadband IR source, the Michelson interferometer, interferogram generations, and the FFT transformation. There's also the FTIR advantage, that is the Felget advantage, Jacquinot's advantage, also the Konitz advantage. And lastly, there is the special regions, that is functional group region and also the fingerprint region. So there are also the sampling techniques and application of FTIR. The sampling modes, that's transmission, ATR, also diffuse reflectance and specular reflection. And also we have the major applications, that's polymers, environmentals, biomedical, pharmaceutical, food industry, and also quality control. And lastly is the key functional groups, that is the O H stretch, CO stretch, NH stretch, and CH stretch. This major applications, it is could identify the crystallinity, oxidations, and degradations, that also the microplastics, also the detections, pollutant, and also the identifications. Okay, so this is the conclusions of my presentations. This is the key takeaways. Atomic absorption has measured metals concentration at the ppm and ppb levels. The UV visible have quantitative analysis via Beer-Lambert law and essential for pharmaceutical. Also the simultaneous thermal, that is combining the TG and DSG, and had a wide temperature range 150 minus 150 Celsius to 2400 Celsius. Also the FTIR spectroscopy, that is the molecular and identifies the functional groups and confirm structure. Also the non-destructive with a minimal sample prep or ATR. So this is my reference for the atomic absorptions, UV visible. There are also the simultaneously thermal and also the FTIR spectroscopy. Okay, thank you for your kindness, lecturers and also laboratory assistants. Good morning, good afternoon, good evening, and good night. Thank you.